Okay, 7.2, Properties of Parallelograms. So starting off, we have the definition of a parallelogram. It is a quadrilateral, that means four sides, with both pair of opposite sides parallel. All right, so it would look something like this, with the opposite sides parallel. All right, and those little arrows signify that they are parallel. Then we have Theorem 7.3, the parallelogram opposite sides theorem. So it says if a quadrilateral is a parallelogram, then its opposite sides are congruent. Right? Opposite sides are congruent. We got 7.4, the parallelogram opposite angles theorem. If a quadrilateral is a parallelogram, then its opposite angles are congruent. 7.5, parallelogram consecutive angles theorem. And what does consecutive mean? Consecutive means next to, right? So parallelogram consecutive angles theorem, it says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And supplementary means adds to 180 degrees. Lastly, we have the parallelogram diagonals theorem. If a quadrilateral is a parallelogram, then its diagonals bisect each other. And to bisect means to cut in half. Now, it would be a good idea to have these written down, and I would write down these numbers as well, because on homework, I'm not going to make you write out the whole thing. So say you use, and this is the answer, the parallelogram opposite sides theorem. On the homework, you could just write down 7.3 theorem. That would be okay with me. Kind of save you a little bit of words. Now, in a picture, let me draw a picture here. All right, there's my picture. What this tells us is that the opposite angles are congruent, like that. Opposite sides are congruent, like that. It tells us that if this is A and this is B, A plus B is 180, right? Those are the consecutive angles. And then additionally we have, and this is probably going to mess up my picture, but we have the diagonals bisect each other. So if these are my diagonals, then this is congruent to this, and that is congruent to that. Okay, those are all things that we could know from these theorems here. All right, let's go down here. Number 1, find the value of each variable in the parallelogram. Now I'm starting off, let's deal with the sides. We've got this side and this side. We know that they are equal, right, by theorem 7.3, the parallelogram opposite sides theorem. So I can say 20 equals z minus 8. So it should be pretty easy for us to see that 28 is z, and there's one of our answers. Now we need to deal with our angles. Our angles, we know that these are also congruent by the 7.4 theorem, parallelogram opposite angles theorem. So I can say 105 equals d minus 21. So what is that going to be? 126 is d. And there we are. Number 2, find the measure of angle B. Well, angle B is right here. Let's call it x. These are consecutive, right? They're next to each other. So I'm going to say that 51 plus x is 180. Now, whenever I subtract here, let me find a calculator. I'm going to type in 180 minus 51, and I get x equals 129. And we could put the degree symbol there if we wanted to. Number 3. We're supposed to find m and n. Well, starting off, let's find m, right? M is going with this angle. That is equal to the 72, right? So I can say 2m equals 72. So m, I'm going to divide by 2, and I think that's going to be 36. But let me make sure. 36. There we are. And then n would be a consecutive angle or an adjacent angle. It means that it's next to. So I'm going to say 72 plus n is 180. So I type in my calculator 180 minus 72, and I get 108. So n equals 108. And again, I'm not super picky about the degree symbol here. You can use the degree symbol. You don't have to. It doesn't bother me. All right, next up, we have a proof. And this is a new thing for us in this chapter. It's telling us that given A, B, C, D, and C, E, F, D are parallelograms, we're supposed to prove that AB, that's here, is congruent to FE, that's here. Now for this proof, I'm going to use a table proof for a statements reasons chart. Statements and reasons, right? In a statements and reasons proof, we always start off by listing what was given. So I'm going to say, well, number one, given is that A, B, C, D, and C, E, F, D are parallelograms. Okay, that's my statement. And then in the reasons category, or the reasons column, I have to say, how do I know that? Well, that's given. So I can just say that it's given. Next up, so let's think about this for a second. Let's think about our picture here. We're supposed to prove that this and this are equal. Well, because ABCD is a parallelogram, right? ABCD is this guy here. Because that's a parallelogram, I know that opposite sides are equal. I know that those purple sides are equal. And then I can say that this guy's a parallelogram, so these two guys are equal. Okay? So my next statement here is going to talk about the opposite sides. Let me erase these. I can say that AB, right, that's this side, is congruent to DC, right? Because what theorem would that be? What theorem is it that opposite sides are equal? 7.3, the parallelogram opposite sides theorem. So I'm going to call it the 7.3 opposite sides theorem. And I normally abbreviate it to be just THRM. Okay. Now I can also say the other statement with it. I can look at the bottom parallelogram and I can say, well, DC is congruent to FE. Right? Again, because they're parallelograms. Now for my final statement, I'm going to look at AB to DC, DC to FE. So it would make sense that AB would be congruent to FE, right? I just kind of cut out the middleman there. And what this is called the transitive property. Transitive property. All right? And this statement here, AB is congruent to FE. That's what we were supposed to prove, so we are done. All right, this was a pretty quick proof. All right, sometimes the proofs gets a little bit longer. Sometimes they're not necessarily as straightforward as this one. But I'm never going to give you a proof and have it not be true, right? If you're on the homework and you have trouble with some of the proofs that are there, shoot me an email and I'll give you some pointers on those, okay? All right, let's scroll down and look at number 5. 3 vertices of parallelogram D, E, F, G are given. Find the coordinates of the remaining vertex. All right, and the remaining vertex would be the other point. So what would that point be? It would be point F that we're looking for. So let's draw a little coordinate plane. So D is at 0, 2. That's right here. This is D. E is at negative 1, 5. Okay, I'm going to erase this and redraw this. Okay, D is at 0, 2 right here. E is at negative 1, 5. 1, 2, 3, 4, 5. There's E. F, we don't know where it is. And then G is at 4, 1, 2, 3, 4, 0. So it goes D, E, F, which would probably be somewhere around over here, and then to G, and then back to D. So that's what I'm trying to find there. So let's think about this. We're looking here, we're trying to find our last point. We know that a parallelogram has opposite sides that are parallel, right? Whenever we're talking about a coordinate plane on here, we could think about lines and think about parallel lines. Parallel lines have the same slope. So let's look at this line's slope. Well, that would be, what is that, down 3 and over 1? So that would be a negative 3 over 1 slope. What point would have a negative 3 over 1 slope with G? Well, if I were to count up 3 and left 1, it would be right here. So that's probably F. I mean, if I was doing my homework, I'd probably be done right now, but I'm just going to check it just too. Let's look at this guy's slope. From D to G, we go down 2 and then over, what is that, 4? 4. So let's check from E to F. Well, E to F would go down 2 and over 1, 2, 3, 4. So that's good. And I think that's going to be our parallelogram. Let's list this as F is at, what is that? Is that 3, 3? Yep, 3, 3. Alrighty. That is that. I think on the homework, either on this one or one soon, you're going to need the formula for distance. This is distance. And we'll say that we've got a point x1, y1, x2, y2. To find the distance between those 2 points, we're going to have x1 minus x2 squared plus y1 minus y2 squared. Okay, that is the distance formula. You might end up needing that. Sometimes if you look online, they will switch the x1, the y1, and the y2 and x2. That's okay. It doesn't matter what order they are. It just matters that the ones are in the same spot. So if the ones are in the beginning, they have to be in the beginning in both spots, right? So this would be something good to have written down. Make sure that you kind of follow how we did number 5, right? Make sure that you kind of get how those parallelograms work with their parallel slopes, right? Think about that. And on the proofs, if you have trouble with those, make sure not to freak out. Just let me know that you're having an issue, and I would be happy to help you. So, all right, that is that.